What we want to achieve is the platonic ideal of the perfect product.
Elon Musk now says Tesla can build cars with 0 weak spots. At Giga Texas, brand new 50,000-ton gigacasting machines are reshaping the game, producing an entire car frame in just 3.45 seconds, slashing both time and cost in a way no rival automaker has dared to attempt. For the 2026 Model 2, Musk is banking on this very breakthrough to deliver a car under $17,000 to the mass market. Lighter, easier to manufacture, yet still packed with the speed, range, and smart tech people expect from Tesla. So the question is, how does Gigacasting really cut Model 2's price down to where millions of Americans can finally afford it? And more importantly, what features will make it not just affordable, but a profitable EV for retirees and working families? Stick with us. We're covering it all in today's video. Don't forget to subscribe and ring the bell as we push toward 11,011 subscribers. Your click keeps us ahead with the latest Tesla reports. Now, let's dive in. Quick note, specs have shifted since last week, because here, you always get the freshest updates. How will Tesla's Model 2 production line put $7,000 back in your wallet without scarifying performance? Forget the old assembly lines with almost 30,000 parts. Musk hasn't been hiring assembly workers for years. At Giga Texas, building the whole body of the Model 2 only needs 50,000-ton gigacasting machines to cast 3 pieces: the front part, the rear part, and the structural battery pack. But why only with this one simple step Tesla can cut $7,000 off each Model 2? The number of parts is now slashed by 70 times, down to just 423, saving about $2,000 in material and logistics per car. Fewer parts also means fewer joints. Each front and rear casting needs around 100 welds. The structural battery pack needs 70. When these big 3 castings come together, they only need 16 welds, along with aerospace glue rated at 40 megapascal, holding everything seamless. Compare that to a Chevy Equinox EV or Mustang Mach-E, which have more than 5,000 welds. Just one misaligned weld or tiny crack can cause structural issues. On the Model 2, that number drops by over 91%, down to only 300 welds. This also means Tesla doesn't need 40 to 50 workers on the line, like they did for the Model 3, Model S, to handle welding and quality checks, saving around $1,500 in labor costs per car. Robots and inspection machines don't need to run non-stop either, saving roughly 3 kilowatt-hours of energy per vehicle. Sounds small, but over a year of production, that's $50,000 of saving. Musk has already promised a price under $25,000 for the Model 2, but with the quiet changes at Giga Texas, production costs could drop enough to bring it down just under $19,000. This doesn't mean you'll get something like colorful, boxy EVs from China. The Model 2 frame is cast from aerospace-grade 6061T6 aluminum, heat-treated for a tensile strength of 400 megapascals. A single solid cast of this material spreads forces evenly, eliminating stress points you'd find in traditional welded frames. That's why the chassis can last up to 30 years, and you won't throw away thousands for weld fixes every year. With the structural battery one-piece aluminum frame, the Model 2 torsional rigidity is 30% higher than the Model 3, which already safely handled sharp turns at 60 miles per hour safely and withstood 1.3 tons of pressure without deforming. Even better, the Model 2 could end up being Tesla's lightest frame ever at just 120 kilograms, compared to 270 to 320 kilograms current models. That means the car needs less energy to move, and with an LFP battery like the one on the Model Y, its range could increase by about 15%, from roughly 267 miles up to nearly 307 miles per charge. Do you ever get frustrated with all the rattles, squeaks from heavy panels, or constant maintenance on your car right now? Drop Model 2 in the comments if you're excited for its launching to replace all that annoying problems. How can each Model 2 be built in just 4.7 seconds to reach US drivers by 2026? After seeing Tesla's sales fall 13% in the first 7 months of 2025, and BYD's sub-$10,000 models dominate, the launch of a truly affordable car later this year is almost certainly part of Musk's plan to win back the domestic markets. That's why we can count on the first 3 million Model 2s in the US in less than 2 months, just as cheap Chinese electric cars are shut out by new 250% tariffs. Is that out of reach? Not with everything Tesla already has at Giga Texas right now that can crank out cars more than 8.4 times faster than Giga Shanghai. The new Model Y Juniper just dropped last month, already sold out. Tesla builds those at 1 every 18 seconds, and they are expected to account for 80% of Tesla's 501,000 deliveries this quarter. Sounds fast, but the Model 2 is on another level. When the molten alloy at 700 degrees is poured into the 50,000-ton machine, it's shot in at 34 megapascals to instantly fill the mold in just 0.95 seconds. A cooling system with 5 degrees Celsius air and 300 water channels flowing at 500 liters per minute solidifies the block in only 1.5 seconds. In the unboxed process, 3 Model 2's casts are made this way at the same time, taking just 2.45 seconds, before they're transported to a central point on the assembly line and snap-fit into a complete car frame in next 2.25 seconds. Each Model 2 chassis takes exactly 4.7 seconds. And in this process, downtime and delays will be zero thanks to Starlink integrated into the factory. It takes Ford or Hyundai 2 hours to fix a welding error detected on the line. But at Giga Texas, robots and sensors communicate instantly with a latency of 20 to 30 milliseconds and a speed of 250 megabits per second per node. The AI control system can process millions of signals in real time, detect errors, and correct them as they occur, instead of manually checking them at the end of the line. At this pace, US drivers are seeing the Model 2 as early as the first quarter of 2026, and more importantly, no more 6 to 8 month wait like with the Model 3 or Model Y. Order in December 2025, and you could have it in your driveway by January. Pre-orders can be done just on Tesla's site and app. And if you can place that before year's end, Tesla's stacking on extra year-end incentives cutting up to $2,500 off for the first Model 2 buyers. How will the Model 2 add $35,000 to your yearly budget without any extra work? More than just a means of transportation, Tesla is building the Model 2 as a profitable asset with the new FSD V14 that Elon Musk has officially announced. This update has 10 times higher parameters and significantly improved safety, expected to be widely available from mid-November and debut directly on the Model 2. Since early 2025, Tesla has been testing its robotaxi service in Austin and the Bay Area, with more than 1,500 rides covering 15,000 miles. The data is being used to sharpen FSD, especially in tricky situations like multi-lane intersections or sudden cut-ins. According to Tesla's latest safety report, a car on the new FSD only sees an accident after about 6.69 million miles, while human drivers in the US average one roughly every 0.7 million. Tesla also entered a new era of hardware after officially killed Dojo in August 2025 and cooperated with TSMC to develop the AI5 and Samsung for the AI6 chip lines. These chips are designed to be optimized for processing AI directly on the car, with 10 times the power of the HW4, capable of processing trillions of calculations per second while maintaining a latency of less than 10 milliseconds. When launched, Model 2 will possess a powerful AI brain, both safer and smarter, ready for fully autonomous operation. Elon Musk is creating a car that can join a global robotaxi network. That's huge for retirees or families on a tight budget. Instead of leaving the car sitting idle in the garage, the Model 2 can go out to work and bring money home for you. Each trip could bring in $5 to $15, And if the car runs 6 to 8 hours a day, it could easily generate over $35,000 a year after expenses. That's basically the average salary of an office job in the US. But you don't have to clock in, worry about health, or age. It's a passive, regular income that can help you pay for tuition, housing, medical care, and more.
Only 5 days ago, a new $5,000 EV just popped up in China. Geely sub-brand Levin calls it the Smurf. Yep, it's tiny, blue, and costs less than a used golf cart in Florida, but redefining the car market? Elon Musk doesn't play with this toy, because what he's bringing next, the $10,579 Tesla Model 2, is built to change the game entirely. This is not Musk's compromise.
If you have a compelling product and and it is affordable, so the value for money is good, the affordability, people can have enough money to buy it, and the product itself is compelling.
1. How incredibly does the Tesla Model 2 make your daily commute feel like a vacation? Here's the brutal truth about American commuting. The average worker spends 54 minutes daily stuck in traffic, losing 100 hours per year to road rage and stress. But Tesla just cracked the code on turning that dead time into your most productive hours. Specifically, the Tesla Model 2 introduces something revolutionary called the workflow drive system that redesigns the cabin over time. A fold-down tray, built-in 5G network hotspot, and voice-activated productivity tools let you dictate emails and join calls hands-free. That boosts real productivity by 20%. In plain terms, if you currently squeeze 5 hours of useful work out of your commute each week, Workflow Drive can push that to 6 hours. Over 1 month, that is roughly 4 extra hours. Over 1 year, that becomes nearly 48 extra hours you did not have before. The Model 2's 10-inch heads-up display projects navigation and tasks into your line of sight, reducing driver distraction by 40% compared to typical infotainment systems that reduce distraction by 25%. That drop in cognitive load converts to feeling more relaxed and present on the road. When your brain is not fighting for focus, a 30-minute drive starts to feel like a pause rather than a grind. The time optimization artificial intelligence is where things get absolutely mind-blowing for busy Americans. This system learns your schedule, monitors traffic patterns in real time, and automatically adjusts your route to sync perfectly with your calendar commitments. If you have a client meeting at 2 p.m., the car calculates backwards from that appointment and suggests the optimal departure time down to the minute. Urban drivers using this system save 10 hours per month that would otherwise be lost to poor timing and traffic miscalculations. That's 120 hours per year returned to your life, which is equivalent to 3 full work weeks of free time. This is not about luxury features. It is about multiplying your most precious resource, time. The Model 2 does not just make the drive quieter. It makes your commute productive, calm, and undeniably pleasurable. Time is money. And this car targets the 73% of Americans who feel like they're constantly running out of time between work, family obligations, and personal goals. If a car could literally pay for itself through increased productivity, would that change your entire perspective on vehicle ownership? Comment 10,579 below. If you're starting to realize this isn't just about transportation anymore. And you know what? The workflow system is just the beginning of how the Model 2 multiplies your earning potential. 2. Why does the Tesla Model 2 feel like a money-making machine? Here's the revolutionary truth that traditional automakers are terrified you'll discover. The Tesla Model 2 transforms from a depreciating liability into an appreciating asset through 3 income-generating systems that have never existed before in automotive history. These are real programs Tesla is launching that turn your parked car into a 24-hour money printing operation while you sleep, work, or vacation. The Charge Share Network represents the most brilliant monetization of electric vehicle ownership ever conceived for the American market. Your Model 2 becomes a mobile power station that sells excess battery capacity back to Tesla's energy grid, or directly to other electric vehicle owners at charging stations. Based on successful vehicle-to-grid trials already running in California and Texas, Model 2 owners can earn $75 per month selling power at 20 cents per kilowatt hour during peak demand periods. That's $900 annually just for owning a car that happens to be plugged in at the right times. But the RideLend program is where Tesla gets absolutely genius about American hustle culture. When you're not using your Model 2 and the average American car sits parked 95% of the time, Tesla's autonomous network can deploy your vehicle into their rideshare fleet. Based on current Uber driver earnings adjusted for Tesla's superior efficiency and lower operating costs, Model 2 owners earn approximately $150 per month through automated ride-sharing. The Smart Trade Guarantee might be the most financially devastating blow to traditional car dealers in American automotive history. Tesla's upcoming trade-in program, launching after 2027, locks in 75% resale value after 5 years of ownership. Compare this to a Honda Civic, which, according to the 2025 market estimate, retains only 50% of its original value over the same period. For a sub-$25,000 vehicle, that's a $5,000 advantage that goes straight into your pocket when you upgrade. The Model 2 isn't just affordable for young Americans, gig workers, and side hustlers. It's a legitimate financial tool that turns transportation from your second largest expense into an income-generating asset. But how does it adapt to your life like magic? The answer will change everything you thought you knew about smart car ownership. 3. How does the Tesla Model 2 adapt to your life like no other car? What if your car could change as fast as your plans? The Model 2 is like a chameleon on wheels. In America, we switch careers 12 times, move homes 11 times, and completely reinvent our lifestyles every few years. Yet we're stuck with the same boring car configuration for 6 to 8 years. Tesla just shattered that limitation forever. The revolutionary LifeFlex module system transforms the Model 2 from a static vehicle into a dynamic life companion that evolves with your changing needs. Tesla has engineered 12 different interior configurations that can be swapped at Tesla service hubs in just 90 minutes. Picture this. On Monday morning, your Model 2 has professional baby seat mounts for school drop-offs. By Friday afternoon, those same mounting points hold a full freelancer desk setup for weekend side hustle projects. Next month, when you're planning that cross-country road trip, the entire rear section transforms into pet-friendly travel cages with built-in climate control and entertainment systems. The genius of this system targets the core frustration of American car ownership. Traditional automakers force you to buy a new car for each life phase. Tesla lets you upgrade your interior faster than you can update your iPhone apps. The hidden space magic proves Tesla understands American storage obsessions better than any other automaker. The Model 2 packs 550 liters of cargo capacity, which is 25% more than the Chevy Bolt's measly 400 liters, using modular compartments that reconfigure based on your weekly needs. Grocery runs require a different organization than camping gear, which requires a different setup than construction tools for weekend home improvement projects. The Model 2's compartments literally reshape themselves through movable dividers and fold-down panels, maximizing every cubic inch based on your specific cargo requirements. But here's where Tesla gets absolutely brilliant about American youth culture and social media obsession. The Style Shift display system. E-ink exterior panels covering key sections of the Model 2 allow owners to change their car's color scheme, patterns, or even display custom artwork through a smartphone app. The deeper strategy here targets American lifestyle fluidity better than any competitor understands. We're a nation of career switchers, location hoppers, and side hustlers who refuse to be locked into single-purpose products. The Model 2 adapts to your evolution from student to parent to entrepreneur to retiree without forcing you to trade in your investment. If your car could adapt to every major life change, such as a new job or a new hobby, would you ever need to buy a different vehicle again? Comment Tesla Model 2 below if you think that this is truly an EV for your driving. The Model 2 shows that safety, tech, and affordability can coexist in a single car. For seniors, families, and new drivers, it's more than just getting from A to B. It's peace of mind on wheels. And this is only the start. Tesla is quietly redefining what an affordable EV can do. For years, we all know what's most expected from Tesla is something really affordable, not out of reach. And now, in Tesla's Q2 2025 earnings call, they're giving us a real reason to get excited.
We continue to make investments in various aspects of manufacturing.
And that'll make the affordability dramatically greater.
But things are not just about cheaper EV. Tesla is hinting at a full rethink of how their cars are made. Faster, smarter, and at a scale that could shake up the entire market. All this change is building up to the long-rumored Model 2, a compact EV that could launch under $9,000. In today's video, let's see how revolutionary the Model 2's production plan could be, and when over 2 million of these cars could finally hit the road. How 1980s style car building still keeps EVs expensive. For more than 100 years, car manufacturing has been rooted in a labor-intensive, multi-step process. A traditional internal combustion engine vehicle contains over 30,000 individual components, each with its own supply chain, quality control standards, and installation protocols. Both traditional AVs and EVs' fragmented structure directly impacts cost, as manufacturing alone accounts for 52 to 60% of the total vehicle cost. For electric vehicles, which add the complexity of battery pack assembly and thermal management systems, the cost challenge becomes even more severe. Battery cells themselves are not cheap. Even with advancements in lithium-ion technology, average pack costs in 2024 remain around $130 per kilowatt-hour. For a compact EV with a 50 kilowatt-hour battery, that translates to $6,500 just in battery cost before any margins, labor, or supporting electronics. This is why even the most affordable EVs on the market, such as the Chevrolet Bolt or Nissan Leaf, start above $25,000 and often climb higher with options. The problem with traditional car manufacturing is not just the cost of materials. It goes deeper into how vehicles are physically built. Every vehicle is constructed step by step, with each part added in a specific order. These steps are not only numerous, but also tightly interdependent. A delay in one component, such as brake calipers or dashboard modules, can stall the entire production line. On average, assembling a car using traditional methods requires between 20 and 30 labor hours. This figure does not include the additional time or complexity involved in fabricating parts at external Tier 1 and Tier 2 suppliers, or transporting them across multiple regions. All of this adds cost, time, and systemic fragility. Now picture the inside of a typical automotive plant built in the 1980s. Loud hydraulic presses shape steel panels. Overhead conveyors move partially assembled frames from station to station, and dozens of human workers manually tighten bolts using power tools. It is precisely this outdated system that Tesla is working to overhaul. Do you think it's time we stopped building EVs like it's still the 1980s? Comment yes if car manufacturing needs a complete rethink. What makes Tesla's approach to the Model 2 different enough to achieve affordability? To build an electric vehicle that costs under $9,000, Tesla cannot simply reduce part costs or negotiate better supplier deals. The problem lies deeper, within the very architecture of automotive manufacturing itself. At the heart of this shift is Tesla's decision to eliminate geometric complexity from the car's structure. Instead of constructing the underbody from over 100 individually stamped and welded parts, Tesla uses massive die casting machines to form entire sections in a single press. This is not just automation, it is a form of structural minimalism that removes dozens of opportunities for error, misalignment, or material waste. However, redesigning the car's structure is only one part of the transformation. Tesla has also reimagined the way vehicles move through the factory itself. In most automotive plants, the assembly line follows a strict sequence. One broken robotic arm or delayed part can grind the entire chain to a halt. Tesla is replacing this sequential logic with a modular production flow. Each major section of the Model 2, such as the front chassis, structural battery, and rear drive unit, is assembled and tested independently in parallel. Once each module is ready, the final vehicle is essentially snapped together at a central unification station. Internal estimates suggest that this model could reduce total vehicle assembly time by more than 30%, while also enabling smaller and more flexible gigafactories closer to the end markets. The final pillar of this new production philosophy is the battery, not simply as an energy source, but as a core structural element of the vehicle. Tesla's aluminum-lithium hybrid battery introduces multiple breakthroughs at once. Chemically, the substitution of aluminum helps reduce dependence on scarce and volatile lithium markets, while improving thermal stability. Structurally, the battery pack is no longer an isolated box suspended beneath the car. Instead, it becomes the floor itself, integrating directly with the front and rear castings. This removes the need for secondary supports, crash cradles, or complex enclosures, reducing the vehicle's total weight by up to 15% and increasing overall rigidity. Taken together, these three strategies, casting, modularity, and battery, Tesla is expected to cut Tesla's production costs for the Model 2 by 42 to 48% compared to the Model 3, without compromising safety, range, or performance. Can casting, modularity, and structural batteries really make a sub-$9,000 EV possible? Comment Model 2 if you think Tesla's onto something big. Beyond just streamlining the production line, how does the Tesla Model 2 drive down costs without sacrificing utility? The answer lies in Tesla's strategic use of high-efficiency materials and a minimalist design language that simplifies construction while preserving performance. A large part of Model 2's efficiency also comes from Tesla's innovative choice of materials. For example, the Model 2 utilizes 6000 and 7000 series aluminum alloys in its castings, selected for their high strength-to-weight ratio and excellent corrosion resistance. These alloys offer tensile strengths up to 500 megapascal and are ideal for large cast structures due to their thermal stability. Where steel is used, Tesla prefers ultra-high strength hot-stamped boron steel, especially in door intrusion beams and side sills. This targeted use of materials allows the Model 2 to remain lightweight without compromising safety. The estimated curb weight is under 1,400 kilograms, roughly 15% lighter than a Nissan Leaf or Chevrolet Bolt, both of which rely on multi-piece stamped structures. Aerodynamically, the Model 2 benefits from a highly optimized body form with a drag coefficient around 0.23. This is achieved by eliminating traditional design inefficiencies such as exposed door handles, side mirrors with large bases, and underbody gaps. Tesla uses flush surfaces, closed-off front grills, and a full-length aerodynamic shield beneath the car to reduce turbulence. Lower drag means better efficiency, and that directly extends range. With the aluminum-lithium hybrid battery pack integrated into the floor pan, the Model 2 is expected to achieve between 330 and 350 miles per charge, while using a smaller battery pack than the Model 3. Crucially, all of these choices do not come at the expense of durability or lifespan. Tesla uses a high-resilience powder-coated underbody to prevent corrosion, and advanced acoustic dampening within the cabin to ensure comfort without added weight. The simplicity of the design also facilitates maintenance. With fewer components, diagnostics become easier, and repair cycles are shortened. Tesla expects the Model 2 to have a total ownership cost over 10 years that is 30 to 40% lower than ICE vehicles in the same price bracket, thanks to reduced mechanical wear and fewer service interventions. 30 to 40% lower ownership cost over 10 years. Do you want to jump on this chance? Comment ready if driving smarter and saving more sounds like your kind of move. The Tesla Model 2 isn't just cheaper parts or faster machines, it's a whole new approach to car manufacturing. With smarter engineering, simpler structures, and better materials, Tesla proves world-class quality can be affordable. Do you think cars should finally be this smart and accessible? Share your thoughts below.
A mysterious prototype, noticeably smaller than the Model Y, has just been spotted at Tesla's Giga Texas facility. Many believe this could finally be the long-awaited Tesla Model 2. But here's the catch. There are critical design and tech details that Elon Musk never mentioned in Tesla's latest earnings call. How will the design changes impact cost, performance, or range in ways Tesla hasn't disclosed? That's exactly what we're digging into in today's video. How is the mysterious compact Tesla spotted at Giga Texas actually the long-awaited Model 2? For context, Tesla's so-called master plans have always served as the company's roadmap. Phase 1 outlined the step-by-step strategy of funding mass-market EVs by starting with a profitable sports car. Phase 2 expanded into a full energy ecosystem with Powerwall and Megapack, and Phase 3 drilled into the technical scale-up required for a sustainable global economy. Now, with the release of Master Plan 4, Elon Musk is steering Tesla toward its most ambitious goal yet. Not just sustainable products, but a pathway to widespread prosperity. At the center of that mission sits the promise of a truly affordable Tesla, a car priced low enough to compete head-on with the world's best-selling gas sedans. That's why the latest drone footage from Giga Texas has electrified the EV community. On August 29th, longtime site observer Joe Tegmeyer captured images near Tesla's crash test facility, showing a camouflaged vehicle parked between two Model Ys. What stood out immediately was its smaller footprint and slightly different roofline. Clear signs that this was not just another Y in disguise. Wrapped in protective covering, the car appeared ready for structural testing, raising speculation that Tesla is now validating prototypes of its $25,000 Model 2. The timing lines up with Musk's recent comments during the Q2 earnings call, where he confirmed production of lower-cost vehicles began in June, with plans to make them available to customers by the fourth quarter. He stressed that these cars won't drag down revenue or margins, but instead deliver a product people genuinely want at a price point they can finally afford. The sighting immediately caught the attention of EV watchers worldwide. Some noted the proportions could align with Tesla's upcoming Cybercab, the smaller, dedicated robo-taxi Musk has promised, scheduled for mass production in 2025 with pilot runs potentially starting next year. Others argued the more likely explanation is that this is the company's long-awaited affordable car. That argument gained momentum after Elon Musk's Q2 earnings call, where he stated that Tesla had already begun production of lower-cost models in June and would make them available to the public by the fourth quarter. Musk stressed the goal was not to hurt revenue or gross margins, but to deliver a vehicle everyone would love and could finally afford. Against that backdrop, the compact car spotted at Giga Texas may well be the first glimpse of the $25,000 Model 2 moving into physical crash validation. The strongest sign yet that Tesla's promise of an affordable EV is shifting from theory to reality. If accurate, this sighting marks a pivotal step. The shift from strategy to physical crash test vehicles signals Tesla is moving beyond PowerPoints and earnings calls and into the gritty work of engineering validation. In other words, Master Plan 4 is no longer just a vision. The first proof may already be hiding under a cover in Texas. So here's the big question. Do you think the camouflaged prototype spotted at Giga Texas is really the long-awaited Model 2, or is it Tesla's upcoming Cybercab? Drop your take in the comments. Just type Model 2 if you believe this is the affordable Tesla for everyone, or Cybercab if you think it's Musk's robo-taxi project in disguise. I'll be checking the comments to see which side wins out, so don't hold back. Next part, let's take a closer look at this prototype and see what design changes might reveal about Tesla's plans. What changes were spotted on Tesla's prototype, and could they hint at the Model 2's design? A closer look at the latest prototype reveals a series of changes that stand out from earlier versions and offer more clues about what could be Tesla's long-awaited $25,000 compact car. For the first time, a front license plate bracket was visible, a strong sign Tesla is preparing for road legal testing where dual plates are mandatory in most US states and European markets. The repeater cameras were shifted slightly higher and outward, likely to preserve sight lines when the car's oversized butterfly doors swing open, a detail that suggests Tesla is still refining ergonomics for a smaller body style. Most striking of all, the prototype carried physical side mirrors, a regulatory requirement for test mules even though the production version is expected to rely purely on cameras. This echoes the early days of the Model 3 program in 2016, when physical mirrors were used on test cars before digital alternatives were approved. To comply with federal road standards, Tesla also added a temporary bolt-on steering wheel, despite its autonomous first design. Chief Engineer Lars Moravy has clarified in the past that such steering units are wired and functional, but only for engineering validation. Beyond those regulatory add-ons, the prototype's hardware paints a clearer picture of its scale and purpose. The front wheels were bare black steel, smaller than the 19-inch alloys on a Model 3 or the 21-inch options on a Model Y Performance, hinting that production variants may feature 17 or 18-inch rims to balance cost and efficiency. The rear wheels lacked aerodynamic covers, likely removed to evaluate structural stresses during testing. A set of amber reflectors above the wheel arches suggested further compliance with North American safety codes. At the back, the bumper was reshaped flatter and raised higher than on the Model 3, potentially offering an extra 15 to 20 millimeters of clearance for urban driving, over speed bumps, and rougher roads. In one frame, a front door appeared slightly ajar, fueling speculation that Tesla may be housing additional cooling modules or compute units under the frunk area, essential hardware for full autonomy, which requires powerful onboard processing similar to the FSD computers found in today's Model S and X, but miniaturized. Taken together, these adjustments indicate the vehicle is entering critical validation phases: aerodynamic tunnel testing to benchmark drag coefficients, crash testing to verify cabin integrity, and structural durability analysis. For context, the Model 3's drag coefficient sits at 0.23, while the Model Y measures 0.28. Analysts expect the compact prototype to target somewhere near 0.24, competitive with Toyota's Corolla Hybrid, 0.27, and Volkswagen's ID.30.26. Dimensions also appear reduced. Early estimates place the prototype at about 175 inches in length, nearly a foot shorter than a Model 3, putting it squarely in the compact class against the Honda Civic or VW Golf. With full-scale production targeted for 2026, each of these prototypes represents a vital milestone. And while Tesla has marketed the Cybercab primarily as a robo-taxi platform, its smaller footprint, bolt-on driver controls, and affordability goal signals something more. At roughly $25,000, this car would undercut the cheapest Model 3 by nearly $15,000 and enter the same price bracket as mass-market leaders like the Civic. 23,950 base, and Corolla, 22,645 base. The logical conclusion: this prototype may not just be about autonomy, it could be the foundation of the long-promised Model 2, Tesla's first true people's car. If this really is the foundation of Tesla's $25,000 Model 2, we may be looking at the car that changes not just Tesla, but the entire compact EV market. The pieces are falling into place, and the next 18 months will tell us if Elon Musk can actually deliver on this long-promised goal. What do you think? Is this prototype the Model 2 or just another cybercab mule? Do you believe Tesla can realistically hit that $25,000 price point while keeping range competitive with gas rivals? And most importantly, would you buy this car over a Civic or Corolla? Drop your thoughts in the comments. I want to hear from you. Over the past few weeks, Elon Musk has been dropping hints about a brand new, budget-friendly Tesla, the Model 2, set to debut in 2026. Leaked blueprints from Giga Mexico suggest this car could be a key piece of Tesla's Master Plan 4, bringing futuristic technology to the mass market at just around $25,000. Rumors are spreading fast, from aluminum batteries that charge in just 10 minutes, to a solar roof, and even a fully button-free interior. So, what exactly makes the Model 2 a critical step in Master Plan 4? Can it really deliver these futuristic features at such a low price? And how will it impact everyday drivers like you on the road? We'll break it all down in today's video. How will Tesla's Model 2 benefit from next-generation Gigacasting? The 2026 Tesla Model 2 is projected to use second-generation Gigacasting, reducing the vehicle's chassis to just two large aluminum pieces, front and rear. In practical terms, this eliminates hundreds of separate components that are typically required in a conventional multi-piece frame, cutting down on welding and assembly steps. The simplified structure is estimated to reduce the car's weight by around 200 kilograms, equivalent to the weight of two average adult passengers, which translates directly into better acceleration, braking, and energy efficiency. Compared with competitors such as the Chevy Bolt EUV, which relies on at least 10 separate frame castings and weighs roughly 1,616 kilograms. The Model 2's integrated aluminum chassis could bring its weight down to about 1,416 kilograms, giving it a tangible advantage in both driving performance and efficiency. Even compared with Tesla's own Model 3, which uses multiple castings and weighs approximately 1,610 kilograms, and the Model Y, weighing around 2,003 kilograms, the Model 2's lightweight two-piece structure represents a major leap in material efficiency and manufacturing simplicity. This design not only improves driving dynamics, but also simplifies repairs and long-term maintenance, making the Model 2 a more practical and efficient choice for everyday drivers. How could aluminum-ion batteries make the Model 2 a true game-changer? Following the Model 2's lightweight two-piece chassis made possible by second-generation Gigacasting, Tesla is expected to pair the car with aluminum-ion batteries, a move that could maximize the benefits of the reduced weight. Early tests suggest these batteries can fully charge in just 10 minutes, meaning drivers could regain roughly 300 kilometers of range in the time it takes for a typical coffee break, a major leap compared with conventional lithium-ion packs that often require 30 to 40 minutes for a similar top-up. Beyond speed, aluminum-ion cells are projected to last up to 3 times longer than standard lithium-ion batteries, potentially exceeding 1.2 million kilometers of total cycle life for the vehicle, drastically reducing replacement costs over its lifetime. The chemistry is also inherently safer, virtually eliminating fire risks even under extreme conditions, which complements the Model 2's efficient, lightweight aluminum structure to create a vehicle that is both fast to charge and secure to drive. How could a 3D heads-up display transform driving in the Model 2? Building on the Model 2's lightweight chassis and rapid aluminum-ion battery technology, Tesla is rumored to introduce a panoramic 3D heads-up display, HUD, that projects all critical driving information directly onto the windshield. Speed, navigation maps, lane departure warnings, and collision alerts are expected to appear in real time within the driver's natural line of sight, spanning roughly 1.2 meters horizontally across the windshield, eliminating the need for a traditional instrument cluster. This would mark the first time such advanced HUD technology appears in a mass-market EV, previously reserved for high-end supercars and concept vehicles costing well over $100,000. By keeping eyes on the road and integrating augmented reality cues, drivers could anticipate hazards faster, potentially reducing reaction time by up to 0.5 seconds per incident compared with conventional digital dashboards. Compared with the current Model 3, which relies on a single 15-inch center touchscreen, the 3D HUD allows drivers to access information without glancing away from the windshield, improving both safety and situational awareness. Could 180-degree swivel seats turn the Model 2 into a mobile lounge? Following the innovations in chassis, aluminum-ion batteries, and the 3D HUD, the 2026 Tesla Model 2 is expected to introduce front seats that can rotate a full 180 degrees when the vehicle is parked or in autonomous mode, effectively transforming the cabin into a mini living room. With the driver and passenger seats able to pivot rearward, the cabin could create a space of roughly 2 square meters for social interaction, gaming, or mobile office use. The system is projected to support up to 120 kilograms per seat, accommodating a wide range of passenger sizes, and integrate seamlessly with Tesla's interior sensors to ensure safety when seats are in motion. How could AI voice control redefine the Model 2's cabin experience? Building on the Model 2's swivel seats and 3D HUD, Tesla is expected to equip the vehicle with a fully AI-driven voice control system, allowing occupants to operate virtually every function without touching a single button. Commands such as play soft jazz music or lower the rear windows slightly could be executed instantly, thanks to a combination of natural language processing and Tesla's onboard neural network, which is projected to process over 50,000 instructions per second. By eliminating traditional mechanical buttons, the cabin is transformed into a fully minimalist space, reducing clutter and streamlining interaction for drivers and passengers alike. Compared with the Model 3's center touchscreen or the Chevy Bolt's physical controls, the AI voice system in the Model 2 could respond faster, interpret more complex commands, and adapt to multiple users in real time, making daily operations smoother and safer. How could an integrated solar roof give the Model 2 a daily charge advantage? Tesla is also reportedly planning to integrate solar panels directly into the vehicle's roof, enabling the car to generate additional energy while parked or driving in sunlight. Early estimates suggest that under full sun, the roof could provide roughly 15 miles of range per day, which is sufficient for the average urban commute without requiring a plug-in recharge. For comparison, a typical city driver covers around 30 to 40 kilometers daily, meaning the solar roof could cover nearly 100% of daily short-distance travel under optimal conditions. By feeding directly into the Model 2's aluminum-ion battery pack, the energy harvested would reduce dependency on charging stations, complementing the ultra-fast 10-minute charging capability. How could hidden cameras and digital mirrors redefine safety and efficiency in the Model 2? Continuing Tesla's push for efficiency and advanced tech, the 2026 Model 2 is expected to replace traditional side mirrors with compact digital cameras, transmitting high-resolution feeds to interior displays. This design reduces the car's aerodynamic drag coefficient, potentially improving overall range by 3 to 5%, equivalent to an additional 10 to 15 kilometers per full charge for city or highway driving. The interior screens are projected to deliver 1080p clarity, ensuring that drivers can monitor traffic, lane positions, and blind spots even in low-light conditions, enhancing safety at night compared with conventional mirrors. By eliminating protruding glass mirrors, Tesla also decreases the risk of accidental damage in tight parking spaces and improves the car's sleek exterior profile. With these groundbreaking features, the 2026 Tesla Model 2 is shaping up to be a true game-changer in the EV world, combining lightweight construction, ultra-fast charging, advanced HUD, swivel seats, AI voice control, solar energy, and digital mirrors in a mass-market package around $25,000. Which of these innovations excites you the most, and how do you think they will change your daily driving experience? Could a mini mobile lounge or 10-minute battery recharge be the future of city commuting? Share your thoughts in the comments below. If you enjoyed this breakdown, make sure to hit the like button, subscribe to Autogearshift, and turn on notifications so you don't miss our latest Tesla news and analysis.